We've no idea whether there are diamonds behind it or not. We're not geologists, we're just the workers who dig the rocks out from the wall. We get clear instructions, and there we drill. But there are diamonds everywhere. Even if we don't know exactly where, we'll manage to find them.
Part 1. What the companies know and you do not. Every year, thousands of diamonds are pulled out of the ground by enormous companies using refined machinery and advanced science on a truly industrial scale. They move mountains of rock with giant trucks, crush it in massive plants, and separate the crystals with technology that costs many millions of dollars. And yet, in many parts of the world, diamonds are still recovered with methods almost as old and as simple as the ones used to pan for gold in a stream. A person with a shovel, a screen, and a patient eye can walk out onto the right ground and come home holding a crystal that formed billions of years ago. So the real question is not whether these stones are out there, because they clearly are, scattered across rivers and fields and more places than most people imagine. The real question is what those companies and those old prospectors understand about the ground that lets them find diamonds where everyone else sees nothing. Because the rock that carries diamonds toward the surface looks so plain and so lifeless that almost anyone would step over it without a second glance. It shows no sparkle and no obvious color, and a raw diamond mixed into ordinary gravel can look like nothing more than a small piece of worn, broken glass. To prove how easily these stones slip past people, consider what happened to a bank manager named Kevin Kennard on a September afternoon in Arkansas. He was walking a plowed field at a public park when he picked up a shiny crystal the size of a marble, assumed it was glass, and almost never had it checked. That dull crystal turned out to be a diamond of just over 9 carats, and stones of that weight have sold for hundreds of thousands of dollars. He found it lying in the open on ground that thousands of other visitors had already walked across without ever noticing what was resting at their feet. The difference between him and all those other people was not luck alone, because the same knowledge that guides the mining giants is what puts a crystal in your hand. In this video, you're going to learn how that knowledge works and how the same clues the companies chase can appear in the rivers and hillsides close to your own home. You will learn to recognize the plain rock that carries the diamonds and to read the trail that nature leaves once that rock begins breaking apart on the surface. And you will come away able to look at a stretch of ordinary ground and judge with real reasoning whether it deserves a closer look or none at all. Everything starts with understanding why diamonds hide inside rocks that look so ordinary, and for that, you need to know where these crystals actually come from. Diamonds form more than 90 miles below the surface, in a zone of the mantle where extreme heat and pressure force carbon atoms into the hardest structure found in nature. A crystal sitting at that depth would stay there forever if the planet did not occasionally produce a very rare and extremely violent type of volcanic eruption. That eruption pushes a column of molten rock upward at tremendous speed, carrying fragments of the deep mantle along with any diamonds trapped inside them. The speed of that ascent matters more than almost anything else, because a diamond that rises too slowly transforms into ordinary graphite along the way. Estimates suggest the magma can climb from the deep mantle to the surface in a matter of hours, which makes these eruptions unlike anything in recorded history. No kimberlite eruption has ever been observed by human beings, because even the youngest known pipes formed thousands of years before written history began. When the material cools, it hardens into a rock called kimberlite, and the structure it leaves behind is a vertical pipe that narrows steadily as it goes down. The pipe itself never creates a single diamond, since the crystals are far older than the eruption and simply ride upward inside the molten column. Many diamonds recovered from mines are older than 3 billion years, which makes them some of the most ancient solid objects a person can ever hold. Geologists first recognized this rock in the mining town of Kimberley in South Africa, which is why it still carries that name everywhere in the world today. Fresh kimberlite is usually dark bluish gray to greenish gray, colored by a soft mineral called serpentine that forms as the original olivine breaks down. The old miners in South Africa called this material blue ground, and it often feels slightly greasy or soapy when you rub a broken surface with your thumb. Closer to the surface, the same rock weathers into a crumbly yellowish-brown clay, which those same miners knew by the simple name of yellow ground. The very first diamonds at Kimberley were pulled out of that soft yellow material because weathering had already done most of the crushing work for free. In the early years, miners even spread the harder blue ground in open piles and waited for rain and sun to break it down before they searched through it. At Kimberley, they eventually dug one single pipe by hand until it became the largest hand-excavated hole on the planet, all in pursuit of that dull blue rock. So when you picture a diamond-bearing rock, forget any image of something sparkling or exotic sticking out of the landscape and demanding your attention. What you should picture is a dull greenish-gray rock that crumbles more easily than basalt, often stained yellow or brown wherever air and water have reached it. Look closely at a fresh piece and you may see rounded green crystals of olivine, small flakes of mica that catch the light, and angular chunks of completely different rocks. Those foreign chunks are called xenoliths, and they are pieces of every rock layer that the eruption smashed through on its violent trip toward the surface. A broken texture full of trapped fragments is one of the strongest visual clues because it records the explosive way this material arrived from the depths. And here is the number that surprises almost everyone who studies diamond mining for the first time because it changes how you think about these deposits. Even inside a world-class diamond mine, the diamonds themselves make up less than 1 single part per million of all the rock that gets dug up and crushed. That means a company can process an entire ton of ore and recover a quantity of diamond that would fit comfortably on the very tip of your finger. It also means that staring at a boulder hoping to spot a diamond sticking out of it is one of the least effective search methods ever attempted by anyone. More than 6,000 kimberlite pipes have been identified around the world since those first discoveries in South Africa well over a century ago. Fewer than 1,000 of them carry any diamonds at all, and only a few dozen have ever held enough stones to justify the enormous cost of building a mine. In the United States, these rocks are better documented than most people imagine, with around 40 pipes mapped near the border between Colorado and Wyoming. Arkansas holds a close cousin of kimberlite called lamperite, and that is the rock feeding diamonds into the very field where Kevin Kennard made his find. Diamond-bearing pipes also appear in Montana and northern Canada, along with vast producing districts in Africa and Russia and Australia. Over millions of years, most pipes also disappear under layers of soil and sediment and vegetation, leaving absolutely nothing visible at ground level. The problem is that a typical pipe measures only a few hundred yards across at the surface, hidden inside landscapes that stretch for hundreds of miles around it. Finding one by wandering around and inspecting random rocks would take several lifetimes, so the companies developed a completely different strategy. There are really only 2 ways a diamond ever leaves a body of kimberlite, and understanding the first one is what makes the second one make sense. The first way is the industrial method, the one the giant companies use, and once you see how it works, you will understand why an ordinary person can copy part of it. That method is built on a simple fact of chemistry, and it is the closest thing the entire diamond industry has to an actual trade secret. A kimberlite eruption never carries diamonds alone because the same blast drags up enormous quantities of other minerals formed in the deep mantle. Geologists call them indicator minerals, and for every single diamond in a pipe, there can be millions of these companion grains scattered through the rock. The most important one is pyrope garnet, a variety of garnet with a deep red color that often shifts toward purple when you hold it against the light. The second is chrome diopside, a small crystal with a green so intense that it looks almost artificial next to the faded colors of ordinary river gravel. The third is a magnesium-rich form of ilmenite, a black grain with a metallic shine that stands out clearly inside a pan of freshly washed sediment. Chromite completes the group, another dark and heavy oxide that survives almost anything the surface environment can throw at it over millions of years. None of these minerals is worth much on its own, Yet together they are worth more to an exploration geologist than almost any instrument money can buy. The reason lies in what happens after a pipe reaches the surface, when rain and frost and rivers begin grinding the soft rock down over millions of years. Water carries those tough little grains out of the pipe and spreads them down every stream and gully that drains the surrounding stretch of land. The result is a trail of mineral evidence that can stretch for many miles, growing steadily richer as you move closer to its hidden source. Exploration crews collect bags of sand and gravel from stream beds across a whole region, then concentrate the heavy grains by density back in the laboratory. Technicians spread those concentrates under a microscope and count every red garnet, every green diopside, and every metallic black grain they can recognize. When the counts rise along one drainage and fall along another, the geologists simply follow the richer branch upstream toward the hidden source rock. Chemistry then adds a second layer because laboratories measure the chromium and calcium locked inside each garnet to read how it grew. Garnets that formed close to diamonds carry a recognizable chemical signature, and a pipe whose garnets show it moves straight to the top of the list. For decades, the exact numbers behind that garnet test were guarded knowledge, shared quietly between a handful of laboratories and the largest producers. The most famous proof of this whole approach played out in the frozen wilderness of northern Canada, and it made two stubborn geologists very wealthy men. In the early 1980s, Chuck Fipke and Stuart Bluesen picked up traces of indicator minerals in samples taken near the Mackenzie River Valley. They realized ancient ice sheets had dragged those grains far from their source, so they began tracking the trail back in the direction the ice had come from. That pursuit lasted roughly 10 years and covered close to 400 miles of remote territory, sampled bag by bag with float planes and helicopters. In 1990, Fipke finally spotted a bright green chrome diopside crystal on a ridge beside a small round body of water called Point Lake. Because that soft mineral cannot travel far, he knew the source had to be right there, and drilling soon confirmed a whole cluster of diamond-bearing pipes. The find set off one of the largest claim-staking rushes in history, and the Ekati mine opened in 1998 as the first diamond mine in Canada. The companies also search from the air, flying instruments that measure tiny changes in the magnetic field of the ground passing below the aircraft. Kimberlite often carries more magnetite than the rocks around it, so a buried pipe can appear on the survey map as a neat and almost circular anomaly. In flat glaciated country, the pipes reveal themselves another way, because the soft rock erodes faster and leaves round depressions that quietly fill with water. Several of the richest pipes in Canada were found sitting directly underneath small circular lakes for exactly that simple geological reason. Once a promising pipe is confirmed, the extraction itself begins. And this is where the pure scale of the industrial approach becomes almost hard to picture. The company opens a vast pit and hauls out the kimberlite in giant trucks, feeding thousands of tons of rock at a time into crushing and washing plants. Remember that even in a world-class deposit, the diamonds make up less than 1 part per million, so mountains of rock are processed to recover a small cup of stones. Inside the plant, the crushed ore passes over tables coated in thick grease because diamond clings firmly to grease while the wet waste minerals slide away. That single trick works because diamond naturally repels water, and it has quietly helped recovery plants separate stones from gravel for well over a century. All of that machinery exists for one reason, which is to do by brute force what erosion in a river does slowly and completely for free. That free work of erosion is the whole reason an ordinary person can find diamonds at all, using tools almost identical to the ones used to pan for gold. When a pipe weathers, it releases not only the indicator minerals, but the diamonds themselves, washing them into the same streams that drain the source. Diamond is chemically tough and physically almost indestructible, so it survives that long journey downstream even after its host rock has fallen apart into clay. It is also denser than quartz and most common stream material, and that difference in weight controls exactly where a current lets the crystal come to rest. Heavy grains sink toward the bottom of moving gravel and gather in natural traps, the very same places where gold and black sand collect in any river. Those traps include cracks in exposed bedrock, the downstream side of large boulders, and the inside curve of every meaningful bend in the channel. The deepest layer of gravel sitting directly on bedrock is the richest zone because heavy minerals slowly work their way down through everything above them. Old prospectors also dug the gravel benches perched above modern rivers because ancient channels concentrated heavy stones there long before the river moved. Your basic kit is a shovel, a bucket, and a set of screens, and you simply wash and sift the gravel the same way a gold panner works a promising bar. If you sift that material and find red garnets sitting beside shiny black metallic grains, you are holding the exact evidence the companies pay fortunes to collect. A single fresh green diopside grain in your screen is an even stronger signal, since that soft crystal cannot have traveled far from the rock that released it. Slopes below a weathered pipe behave the same way, shedding loose crystals downhill into gullies where every rainfall concentrates the heaviest material. That is why searching pays off most right after a strong rain, when fresh dirt has been washed clean and dense grains sit exposed on the open surface. At Crater of Diamonds, the staff plows the search field for this exact reason, and many of the best finds happen in the days that follow a heavy storm. None of this helps unless you can recognize a raw diamond when it finally appears, because a rough stone looks nothing like the gems in a jewelry window. A rough diamond rarely shows sharp, sparkling facets, and countless valuable stones have been tossed back into rivers by people expecting exactly that. What it shows instead is a rounded shape with slightly curved faces. The luster is the real giveaway, because rough diamond carries an oily metallic shine that keeps glowing even when the stone is coated in dust and grime. Quartz looks glassy and watery beside it, and quartz crystals tend to grow as six-sided columns with flat faces that a diamond almost never displays. You can also wet the stone, since diamond repels water so droplets bead and roll off, while a grain of quartz stays evenly covered in a thin film. Density gives a quiet clue too, because a diamond weighs roughly a third more than a piece of quartz of the very same size resting in your palm. An inexpensive ultraviolet flashlight helps as well, because a good share of natural diamonds glow with a soft blue light under that kind of beam. Treat that glow as supporting evidence only, since many real diamonds show no reaction at all, while a few other minerals respond very brightly. Hardness is the final confirmation, since diamond sits at 10 on the Mohs scale and will scratch every other natural material found on this planet. A smarter check is to drag one edge of your stone gently across a piece of common quartz and see whether it leaves a clean and permanent groove. When you are unsure out in the field, keep every candidate stone in a labeled bag and run your comparisons calmly at home with clean water and good light. So where can you actually put all of this to work without breaking a law or wasting your time on hopeless ground far from any real source? The obvious starting point is Crater of Diamonds State Park in Arkansas, where the eroded surface of a diamond-bearing pipe is open to the public every day. Visitors there keep whatever they find, and the park registers hundreds of diamonds each year, with one or two turning up on an average day of searching. The district along the border of Colorado and Wyoming holds dozens of mapped pipes, and one of them even supported a small commercial mine back in the 90s. Streams draining that area have produced diamonds along with plenty of red indicator garnets, which makes it a serious destination for a prepared prospector. Farther east, the story turns stranger because ancient ice sheets dragged diamonds out of Canada and scattered them across parts of the American Midwest. Farm fields and creek gravels in states like Wisconsin and Indiana have yielded scattered stones for over a century, though their true sources stay unknown. Wherever you go, remember that most promising ground sits on private property or on somebody else's active mining claim, so permission comes before any digging. Respect posted land and protected areas. Fill in every hole you open, and keep your expectations honest, since the typical find is a small stone or a few grains. Those small finds are exactly what you want to see because they prove the geology is real and that heavier crystals are moving through the same drainage. There is something you should know before you head out, because the diamond is not the only gem this same kimberlite quietly leaves scattered across the ground. 2 other precious stones ride up in that very same rock, and both of them are far more abundant than diamond and far easier for a beginner to actually find. The first is the red pyrope garnet we met earlier as an indicator mineral, because that same grain is a genuine gemstone in its own right. For every diamond a pipe releases, it sheds millions of these garnets, and the cleaner deep red ones are cut into faceted stones sold as Cape Ruby. When you find those red grains in your screen, you are not only reading a signal, you may be holding a small gem that already has real value on its own. The second gem is peridot, which is simply the clear and glassy form of the olivine that makes up most of the body of the kimberlite itself. Where that olivine grew clean and free of flaws, it turns a bright olive green, and good peridot holds steady value with collectors and jewelers alike. So the very rock you are learning to read for diamonds can hand you 2 more gemstones that show up in far greater numbers with far less weighting. Learning to tell all of these apart with confidence takes real practice, and that is exactly the kind of training we work through in the members area of this channel. Members get exclusive videos where we go deeper into identification, valuation, and the field methods that never make it into the public uploads. If you want to support the channel and speed up your own learning at the same time, you can join through the button below this video for a symbolic amount. And if this is not the right moment for that, simply subscribe for free and keep learning with the next video that is appearing on your screen right now. Thanks for liking and subscribing. Good luck, Gem Hunter!